Welcome to AxisVM. This video will highlight some of the plastic analysis capabilities of AxisVM using the steel frame model described in detail in the step-by-step tutorial that can be found on the AxisVM website. In order to include plastic behavior of the steel material, the nonlinear properties checkbox was selected along with the plastic von Mises material model. A tangent modulus of 1/1000th of the initial modulus of elasticity was specified, allowing for slight hardening, which in this case will be isotropic. The tangent stiffness was selected for the Newton-Raphson iterations. The nonlinear static analysis was performed for the load combination CO number 1. A displacement incremental solution control was selected for node 18 with 100 millimeters in the x direction over 50 steps. The default convergence criteria were adopted for displacement, force, and work with up to 32 iterations. The store last increment only checkbox was disabled to allow the observation of the nonlinear behavior over all the increments. With the analysis completed, the displacements are shown on the deformed shape for the last increment, the 50th. Let's examine the progression of the plastic hinges in the intermediate frame. For better visualization of the intermediate frame's results, the corresponding part is activated. Select the stress minimums and maximums results display, S-min-max, in the filled diagram mode. It appears that several sections of the frame reached the yielding stress of 235 newtons per millimeter squared. An animation can be made to run through the increments to observe the evolution of the plastic events. The animation can be paused or advanced increment by increment, and it is found that the first yielding occurred in increment number 13. Use the XY diagram icon to display the load displacement diagram corresponding to the control node. The cursor can be moved to increment 13 to indicate the starting point of the nonlinear behavior. Then enable the second diagram. For the x-axis, select the deflection of the first level beam midpoint node, and for the y-axis, select the maximum stress component, S-max. By moving the cursor over the yield point in the red diagram, the increment number corresponding to the yielding of the beam's midpoint can be determined. In this case, it will be number 33. The blue diagram allows for observation of the impact this yielding had globally on the structure's behavior. A slight change in slope can be seen. To inspect the stresses along the first level's right column, first switch to increment 13 and then click on the column. The distribution of the various stress components along the length and over the cross-section of the column can be seen for any increments. After moving the cursor over the section corresponding to the top of the column, running through each increment shows the progression of the cross-section yielding in a state of biaxial bending with axial force. These were just a few highlights of the productivity tools for plastic analysis within AxisVM. Thank you for watching, and please visit the AxisVM website for more information.